It's easy to find. I've had a channel for a while. I haven't posted this semester yet, but I'll fix that. So once again, all these things, they're talking about the inverse what up here? Operations, right? The opposite is my additive inverse, adding up to 0. Multiplicative inverse, that's the reciprocal, multiplying to give me 1.
Yeah.
Inverse of a square is a square root, right? Inverse of a square root is a square. I'm going to continue with all this to help us understand inverse functions. So here's what I need you to do. I believe this is maybe page 5 or 7, maybe 7?
8.
8, I lied, I'm so sorry. So page 8. Don't worry about the patty cake part. I'm going to speed this up a little bit because we only have so much time. Page 8. Page 8. M3-8. Okay? So, we should see this funky little polygon, and notice I'm just going to focus on A. What is this set of directions asking us to do with that polygon?
Describe how you can use your trace to show a reflection.
So I'm going to focus on this. We're looking at a reflection across the line y equals x. What do you know about the line y equals x?
Up and down. One down, up.
First, hey, back up. There's multiple ways to do this, right? But what's the most common equation you know for a line?
Y equals mx plus b.
Yeah.
So what's my m got to be? Yeah, but in this equation. Let me ask you this. Let me ask it a different way. How many x's do we have?
1.
So my slope is what?
1.
1. What's my b?
Why?
It is the y-intercept, but what is it this time? If there's nothing there, we have to be adding what?
1 or 0?
Right, if you're adding 1, you got to show plus 1, right? But do you have to show plus 0? No, right? So it must be 1x plus 0. And so y-intercept is 0, and a slope of up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. So notice this line right here is y equals x. So there's my line that I'm reflecting across. Alright? Another thing I'll point out is this, a little bit simpler. If I say y equals x, what does that tell me about x and y? They are what? If y is equal to x, what does that tell me about x and y? Are they?
No, they.
They're not just similar, they're not opposite. Say it again. Not equivalent. They're equal, right? But literally we're saying that they're equal. If x is negative 2, what's y? Negative 2. If x is negative 1? If x is 0? Notice, it's just whatever x is, that's what y is, right? So, but that's that line that we have up here. Now, I need us to talk a little bit about how we do reflections like this so that you can do the next little piece a little bit on your own. If I were to take this point F and reflect it over this line, could it be right here? Or maybe right here? It's across it, right? So is that the correct place for it to be? So how do you know it's here and not here?
Yes.
So when we do a reflection, we need to know something very specific about reflections. Reflections are always perpendicular to the line of reflection. So when I look here at F, here is that line, and that's perpendicular to that line, okay? How many squares did I go to get to the line? So how far am I going to go to the other side? That is F prime. Prime just means what happens after the transformation, after the reflection. Okay? So it's just got to be perpendicular to the line.
Wait, would you say that again?
The prime. That's it's read F prime. It just means what's after the transformation. Okay? Yeah, prime time. There you go. So would E go here?
No.
Would that be perpendicular? No? What about here? That's perpendicular to this line?
No.
I say, does that look like perpendicular to you?
Would it be F in you?
So would it be what?
Or the F is?
Not quite. Remember how with F we had to go the same distance to the other side? So how far do I need to go? That's where E prime would be. Notice it needs to be perpendicular. If I draw a little imaginary line, right? That's perpendicular, meaning it creates what kind of angles? Oh guys, perpendicular, right angles, 90-degree angles. So, one thing I'll point out is, if this slope is 1, perpendicular will have a slope of -1. So, how many squares did I go for D? 3, so how far do I need to go to the other side? There's D prime. Alright, find the rest of your points reflected. If you need help, let me know. But find out where, oh, last one I will point out. Here's G. If it's on the line, where is G going to go? It stays on the line, right? It is on the line. There is no distance for it to reflect, so this is G prime. So, find all your reflections, label them, and then draw the figure to make sure it looks right, that it is in fact a reflection across that line. Draw all the reflections across the line y equals x, right? And across the line. Boom. Went 2 here, so 2 to the other side. Stays where it is. This, 1, 2, 3, 1, 2, 3. Make sure you label them. Now, reflect across. Reflect across. Finish reflecting those points.
I don't get it.
See how you went half the square to here? So you go half the square to there. That's it. That's C prime. C prime. Yep. Use that for B. So, where's C going to go? Where's B going to go? Where's A going to go? Well,
Which confusion me?
so it's, we'll count to the line, and it goes the same distance to the other side. See how I went 3 diagonals to here? So I go 3 diagonals to here. Half a diagonal, half a diagonal. Here, 2 diagonals, 2 diagonals. So how far is this one going to go to the other side? Like a full one to like right here? Or just half a one? That's it. Okay? Guys, whatever the distance is to that line of reflection, that's how far you go to the other side. Draw your figure to see if it works. Yes, ma'am. Does that look? See E right here? And so you see how here's the line that's reflecting over. So that's half of the diagonal or half of the square. So I go half to the other side. There's E prime. Here's F. 1, 2 to get to the line. So how far do I go to the other side? How far does it take me to get here? 2. So I go another 2 to the other side. Okay? D just stays there because you're on the line.
D or B?
D, how far? 1, 2. So how far do the other side?
Can't imagine.
Well, 3 and then 3 to the other side.
I don't like it.
Okay?
You heard to put D. Dumb boy.
That's ridiculous.
How far is
So
this
that's a
point?
D.
I feel like actually my soul like it's like.
And how far is this point from the line? 1, 2, 3. 1,
Like how
2,
far it
3.
is from the-
That's the right.
That's E prime. This is D prime. Okay.
I can't.
Once you have drawn your figure, so make sure you do the rest of the points, right? We haven't done C, we haven't done B or A. Make sure you reflect those across.
Mr. Kennedy, would you have to do that?
Huh?
Would you have to do that?
Well, it's on the line, so is it going to move or
No.
change? Okay. So I need you to draw your points. And after you get your points on there,
Yes.
I want you to, well, I do want you to sketch the figure, but more importantly, I want you to identify the coordinates of all these points.
Well, that's the easy part,
By the way, does that look like the same figure on the other side?
Yes.
Okay? We're going to go over them all in a second, but I'm just giving this as time for those who have not finished drawing that figure. Let me know if you have questions. You need to make sure that you're careful. 1, 2, 1, 2. It's got to stay there. This
Wait,
one
no,
is
why
half
is it going
across, so we go
There you go.
half across.
Yeah,
1,
yeah, why?
so 1, 2,
You said what?
half again. So half.
You said you can eat up on that meat.
1, 2.
You know it ain't good.
Now draw.
You know,
And connect those points. I'll probably label them as well.
I ain't gonna lie to you. I'm gonna die soon, you know.
If it's on the line, then
why don't you say something like that?
Hold up. You made a.
I don't care about this.
Oh, this, you never reflected this point. 1, 2.
Because it's on the
1,
origin.
2.
It's on the eighth, I'm sorry.
It should
No.
be here.
What's up?
It should be here. It's here.
1 kg
It's
and
here.
KD beef.
Go ahead,
Should have
Trey.
been 1
They raw, you
and a
trying
half.
How you a hot
Ain't a football there.
to No, you got no steel,
You
man.
only bought it twice this
You
year.
got it.
You be right.
You got no good.
My check. You be right.
Alright. So let's investigate this figure. Guys, please make sure you pay attention.
Where they gonna use it?
I'm so sorry. I'll quit helping people in the middle of class.
You said pay attention.
I was
So, B right here. What are the coordinates for B? B close.
I got right there.
Six.
6.
Negative 6.
Negative 6. Oh, wait, you talking about right here? This
Negative
nigga 5.
Negative 5,
Negative 5.
comma,
Negative
negative 2.
Oh, yeah.
Y'all heard the first
I
time.
thought we was running on the other ones.
It's okay. Now let's look at B prime. What are the coordinates for B prime?
They didn't be 6. Hold on.
That is-
Positive
No. Negative 6.
6? Yeah.
I would say, how far do I go to the left?
Oh, that's 2.
2.
That's 2.
How far do I go down?
Yeah. Negative 6.
5. Count.
5, right.
Tripping, right?
1, 2,
tweaking.
3, 4, 5, right?
Yeah. That's
So
the bottom
make
of
sure if it's to the left, it needs to be negative.
that. But that graph
To
number.
the Y, or if it's down, it needs to be negative. I want you to look at those points. And I want you to think about it for a minute. Don't make any predictions out loud. But I want you to start thinking about, maybe there's a relationship there.
Mm-hmm.
Maybe there's a pattern. Let's look at C. What are the coordinates for this C right here? Remember, X is first, so negative 1, comma. Okay. So what about C prime?
Run.
Is that correct, or does someone want to push back on that? Or ask a question about that?
Wait, we talking about, you said the prime?
Someone see it.
Yeah.
C versus C prime. So
What is still?
it's down, isn't it?
It's still the same thing?
Oh, negative one.
So negative 1. So no predictions out loud yet, but you should hopefully start to notice a pattern. We're going to do one more together. And then I want you as a group to come up with one prediction that you as a group are going to write on the vertical surface. You're just going to send one person up to write the prediction. So D, what are the coordinates for D?
I ain't get to it, but it look like it's,
No, positive
negative,
4.
no. yeah.
Positive 4 and
Negative
negative 2.
2. Yeah.
Alright, anybody want to add on to or push back on that?
Hold on.
Remember,
You said we do X first, right?
I would say X always goes first,
So that
right?
means negative 2 to.
Negative 2, comma.
Yeah, my bad.
You're good.
1 KB.
Calm down.
So that's D. So I'm going to connect that now to D prime. 4 and negative 2.
Okay.
Alright, I want you as a group to come up with a prediction as to what you think is happening when we reflect across the line y equals x. And one person per group, go write your predictions on the board.
It's
Why I gotta
Because you got inverse.
put?
Maybe, but what does that mean here?
I think it's
Can we use the word opposite here? Or is the sign
What does that
changing?
have to do with inverse?
So what's the pattern?
That's not that.
What do we notice is happening at those points?
Yeah, the waves, but it's not that.
So that's why KB was. That's why KB was.
No, they got caught with a gun.
Just say it, speak it out loud. By the way, group, y'all are group 5. Hey guys, don't erase the inverse operation stuff, and Carly, just because of space, can y'all write your answer or one of the chalkboard over here? Okay?
I gotta leave.
Go for it.
I don't say out loud when you watch the live.
Come on guys, I need predictions up on the board. What are we thinking? Just talk it out. What are you thinking?
Saying, should they run them first?
Be careful with the link.
Well, no, I ain't gonna lie.
It's actually kind of close. But what do you add X and Y? So are those, that number right there, X and Y? So the X and Y coordinates, or the X and Y values.
What they gonna
All
do?
right, do you agree with that assessment? So Cameron, Janiyah, what numbers are just coordinates? Okay, so what, when you say the coordinates, what do you mean? Need better, some more language with it.
The X and Y's.
The X and Y's? Let me ask you all this, what's another word for X and Y that we actually used earlier? Say again? Wait, the inputs and the outputs are being switched?
It's 25.
Kind of like with those inverse operations up there?
Yeah, I was gonna write these.
What I say?
Oh, you
Right up there.
But just told you should have been writing up
I
though.
don't know how to read it.
You look like this big mascot.
Oh, you're so sweet. But he's 1.5, he doesn't need to go to Chuck E. Cheese.
You want him to learn math at 1.5?
What's your problem? What do you think he would appreciate Chuck E. Cheese's?
Yes.
1.5?
Yes.
I ain't gonna lie, he probably started crying.
Take it, G.
Chuck E. Cheese, whatever.
Take him to the block.
Oh, you
Take him to the block.
Yeah, the learning block. Yes, the learning block.
I
So-
did, I didn't have the color.
Let's talk about this, right?
Oh, why change?
Ladies and gentlemen, one of the things we ended with earlier was inverse operations. What happened with our inputs and outputs? They switched, right?
Yeah.
What's happening with our inputs and our outputs? Our X and Y values here, they are being switched.
Yeah.
So, last thing that I want you to do before we head to lunch is this. Under the top left, where it says inverse functions graphically and tabularly. Inverses transpose, that's the mathematical term. And what word have y'all been using this whole time?
Opposite.
Not opposite, what did you just say? Y'all have been talking about it's an S word that y'all have. They're being switched or swapped, right? When we say transpose, we just mean switched or swapped, right? So the inverses transpose the inputs, which, what do we call inputs as well? Are they X or Y? They're the X, right? So the inputs and outputs, that's it. So we see that connection here to inverse operations. The inputs and outputs are switched. They transpose. Inverses, both graphically and tabularly, and I should say inverse relations. We're going to talk about it functionally soon. But inverse relations just transpose inputs and outputs. After you have that written down on your sheet, you can head to lunch.
So bad.
Wait.
Call it football coach. This is your player like
Hold on. What's up, Javon?
Shut up your room.
Inverse relationship transpose input and output.
Yeah, right here.
Inverse functions graphically. Well, that's what we were writing earlier, but now we're moving to this side because these are the major notes we need for
And
this.
this right there.
Yeah, inverse relations,
Look.
transpose or switch.
I'm gonna just say on the back.
Ah, it's
I'm
excellent.
gonna just say on the back.
Well, come back and make sure you write there after lunch as well, right?
I might not write on the back.
Yeah.
But I wrote it though.
You sure did. So we have already covered a couple terms. We're about to pick back up with more of them. So what do we conclude with before we head into lunch?
They did similar, they were inverse operation on the graph.
Say that one more time.
You talking about the graph?
No, I mean, what was the last thing we said before we left for lunch?
They were transpose
And output.
The inverse relations, inverse functions, transpose are inputs and outputs. Oh, y. I forgot to include y with that. So inverse relations, transpose, inputs and outputs, because, not just the word because, what's the big thing that we did that caused those inputs and outputs to transpose? I don't think we had to subtract anything. We reflected. What did we reflect?
All right.
I'm not sure.
There we go. We reflected the relation across. Across what? Y equals x. We reflected across the relation across the line y equals x. So the inverse, I would add that onto that piece. I can't believe I forgot to mention that detail. But it's not just we're magically transposing inputs and outputs. We transposed inputs and outputs because we reflected across the line y equals x. Okay?
Treat it like every day.
Dude, mind your business, dude.
Hey, KB. You worry about your learning. KB, you worry about your learning. I'll worry about this classroom. Sound good? Thank you, sir.
Sound good.
All right.
Wasn't even talking.
So
Too bad you don't.
let's look at this a little bit more heavily, right? So what I've done is I have set up a learning activity.
Is it on Mac?
No. There is stuff on Matthew that you can do on your own, but that is not what we're doing right now.
For real, I'll be big.
For real.
For a grade lab.
We may after we get through some of this stuff.
Yes.
Alright. Sorry, I forgot to clear this
I'm
out.
not allowed to work one.
Okay. So let's look at this. So let's start looking at some functions. We're going to add some more in to our understanding about inverses. So, sir, pretty good. Learning. What kind of function do we have here? Concave up what? Quadratic function. Right? The shape of that quadratic function is a what? Parabola. Now, a couple of things I want to point out and I want to establish. Any guesses what this line is that I have? Oh, obviously it's linear. What is the line though?
Oh.
Y equals
Wouldn't it make sense that it's y equals x based on all the conversations we've had so far?
Yeah.
In fact it is. Notice if x is 1, what is y? If x is 4, y is 4, right? Y is equal to x. That's all that line is. And this is going to be the key. Now, we already said if we want an inverse function, what are we going to do to get that inverse? Chelsea? Switch what? Which part? The inputs and outputs. We got to recognize that. Now, we're going to switch, or what's the more mathematical term for that?
transpose.
We're going to transpose our inputs and outputs. But why? What was causing the inputs and outputs to transpose?
Reflection.
It was a reflection. I want you to look right here. Does anyone see any of these options in the graphing calculator that might let me do a reflection?
Nah, I don't.
Nothing? No, not view.
Windows who?
Okay, you know reflections is one of the key parts of geometry.
Geometry.
So I'm going to go to geometry. Do you know what reflections like fall under? What group of ideas that reflections fall under?
Transformation.
They are transformations.
BBS is
Transformation and reflection. There we go. Okay. So I'm going to click on the line of reflection, then I'm going to click the point that I want to reflect. Now I'm going to do 1, 1. Because it's on the line, what's going to happen?
It's gonna be there.
It's going to stay right there, right? It did not move, okay? Now what about negative 1, 1? Does that reflect across?
Yes.
Yeah, it does, okay? So let's do one more. Actually, we're going to do a few more. Okay, that stayed where it is. All right, I'm going to do 2, 4 right here. Did that work?
Yes, sir.
Yeah. One more. I'm going to do negative 2, 4. And so I want us to look right here, and I need you to pay attention to this. So first things first. Does anyone recognize what this would look like if I were to draw a curve through those points?
Nah, I can't recognize it.
Nothing?
No.
It would look like.
Is it going to be exponential? But let's notice, that's an exponential curve.
Right.
If I connect those points, you think it's going to move like that?
No.
Okay, let me draw this. There's couple more points I could put in here, just because I know how it's going to work out. Do you recognize it now?
No.
Say that again, Quay. You think it's going to be a what? Does that look like a parabola?
Yeah.
Yeah. What's the difference this time, though? The direction, right? It's going to the side. So would this parabola be a quadratic function? Why not?
Like if you use the imaginary line on somebody, something like that, you know what I mean? But if you like a pencil or something,
Can someone add on to what Rod's talking about?
please do.
How did it start?
No, because if you put a pencil through it, like it's gonna go through both times.
Does anyone remember what Rod's referring to here?
Hey,
He's talking about some kind of line, huh?
wait.
Not a boundary line. Can you draw it up here?
The X.
Can you come draw what you're referring to?
Can I try?
Yeah. But let Rod draw. Because I want you to see this.
Red gonna go with.
Why are you standing like that?
He's trying to let the projector.
Can you shut up?
Yo, Rod, what about you? I'll take care of it.
You take care of the class, not you. Like it's like
Why you?
Alright guys, I want y'all to look at this. How would you describe that line? All lines are straight. Come on now, what's the direction of it?
It's equal. It's equal.
It's white.
Wow.
Wait, no.
Forward. That we're gonna get to that definition in a second. But guys, what direction would this line be?
Up and down.
Say that again.
It's a vertical line.
Oh, it's a vertical line. So we call it the vertical line.
Oh, symmetry?
Quadratic.
No, vertical line. No, I didn't. I'm my AirPods. Thank you.
Vertical.
I didn't even bring it.
Oh,
The vertical line test.
Oh,
And so
That's a real thing.
that is a real thing. We've covered it this year.
No, I'm talking about like jumping.
Oh,
So what?
Like,
smart.
if you jump,
Yeah. Oh, yeah.
vertical jump.
Right. Yeah. Okay, so right here. Okay.
You got definition.
Hey, right here, vertical line test. But I want to connect this to what Zakayo is saying, because Zakayo is hitting on the most important part. The definition of a function was what? One
And only one.
input maps to,
One and only one output.
there we go. One input maps to
Only one out.
one and only one
Output.
output, right? So each input maps to one and only one.
One and no more. Just one.
Okay, so I want you to think about this. If I draw this vertical line here, what is the input right here? What's the x value? The x value right here? 1, 2, 3, 4, okay? So 4 and 2, 4 comma 2, and this would be 4 comma negative 2. notice that vertical line has the same input or different inputs? Same input. But that one input is mapping to two outputs.
Right.
So is this a function? No. The vertical line test is just a graphical way to check to see if something is a function. And so the vertical line test, we can very clearly see right here, is one input mapping to only one output. Tristan, the input of 4 maps to what numbers? 4 maps to what? Here.
Can you ask that question again, please?
4 maps to what?
2.
2. What does this 4 map to?
Negative.
So does that one input only map to one output? No. Maps to 2 outputs. So is this a function? No. Right? One input is mapping to 2 outputs, not just one.
It's a relation.
So it is not a function. Well, so, okay, one thing I need to clarify. All of these mappings of inputs, outputs are relations to one and only one. That's what I missed. Output. The reason I bring that up is this parabola right here is a relation. It's just also a function, a special type of relation. This relation just is not a function, and that's kind of the focus we want to have here. It is only a relation, not a function.
Name right?
No, I wasn't putting it in right here.
Thank you for putting it up. All right. So, function, one input maps to one and only one output.
That was like a mirror.
Kind of.
Like a who?
So, that would no longer be a function. So here's what I want to ask. Anybody have a prediction what the inverse function would be? How I could type in an equation to get this inverse right here?
You really don't know.
No clue?
This way.
Well, let's look at 2 things. First off,
You can flip the input. Is the air conditioning unit on?
that's what I'm saying. I was literally just saying like, did someone change the temperature?
No, if you.
No, it was not.
Did someone, like I had this at 68 earlier, someone put it at 71.
71.
This are dang special.
I was done.
Right here. F of x equals x squared. Charlie, what do you know about the inverse of a square? Square root? Any guesses maybe what the inverse function might be then? What type of root?
A double root.
No, what type of root? The
What you mean by that?
guys, it's x squared, so I need what type of root?
Square root.
Square root, thank you.
Corey, what you say the quadruple root from?
Michael Jackson.
Okay, so 2 things I want you to, actually let's do this because I should have enough calculators. 1 person per group, go grab a calculator so everyone has one in hand.
I'm talking about HDL. You can close it with the
Hey, please don't get the camera because I'm trying to record.
Hey, black man, your hands off her.
Get real. We hit it up.
Well, we need 1 calculator per group.
What you doing out in
Say again, John. Everybody needs a calculator. Jordan, you gonna go grab a calculator?
HDL, bro.
Come on. Shut up. Alright, I need every person to create a graph page on their calculator.
Nah, that was correct. I don't know.
Shit about that.
Hold on.
I don't want to see me.
Hey guys, when you create a graph page, hey listen, when you create a graph page, go to Windows/Zoom and do Zoom standard for me. You don't want to have something huge. So what I recommend, alright, if you hit the home button, it was right here. Create a new document.
What crazy?
Kind of just that one.
Yep. So hit no, you don't need to save it. Okay. Okay. Then create a graph page. Should pop up in a second. You're supposed to be creating a graph page. So hit menu, add graphs. Okay, so you're good. Now, what graph are we going to type in here? What do we need to do? We wrote it. What is this symbol? Square root of x. So where are we going to find the square root button on these calculators?
Right there.
On the calculator.
Thank you. Where on the calculator?
Control,
there.
and then you go press the square.
So I would say you see x squared. What's in gray above the x squared?
Control.
Square root.
The square root symbol, right? So if you look at the x squared and look at the gray above it, x squared, gray above it is the square root symbol. So you have to hit control and then x squared to get the square root symbol in there. Sir,
But hit control and
control and x squared.
Money.
Acting like you retarded or something.
I understand everything. And then
Yo, chill.
I ain't do that at all.
It's disrespectful.
I told you.
Guys, look right here. Here, it says trig, below it says x squared, and gray above it has a square root symbol. So you hit control and then x squared. Now, notice if you type that in and you hit enter, hold up. What are we, aren't we supposed to have, we said we were going to have two halves, weren't we?
Well, you know,
only got one.
I'm gonna let him.
I thought we were gonna have a ham.
Well, remember when we graphed it like this, we had a top and a bottom, right? Which is why we said it was not a what?
Function.
Function. So let's talk about this. X squared equals 9. If I solve this equation, what do I need to do? So what would that difference be?
Square root.
Square root.
Square root.
And so x equals what? If I type this into a calculator, you type the square root of 9 in, what's the only thing the calculator is going to tell me? 3. You have to remember that it's not just 3. It's plus or minus 3. So here, should I just graph the square root of x?
No.
What do I actually need to also graph?
Negative.
Positive and a negative square root of x. Okay? So type in a positive and a negative square root of x. So remember, hit menu, go to graph entry / edit. All the fun stuff happens in menu, graph entry / edit, go to function, and
Slash what?
do a negative square root of x.
You said square what?
Getting these.
Graph entry / edit, go to function.
Function.
Yep. Okay.
Square root of
You need a positive square root of x, negative square root of x. Does that now give me that entire inverse? Yeah. Now, really quickly, I'm going to go ahead and jump one small detail, but it's an important detail. Hey, Javon. It's a small detail, but it's an important detail. Cameron, Janiyah, eyes up here. I'll help you with the calculator in a second if you need it. I need to remind you of this. What did we say from the beginning an inverse function does?
transpose.
What's transposing? The inputs and the outputs. So if I was to look at this equation, what would this become if I transpose my inputs and outputs? What would the y become? It become what? If I transpose my inputs and outputs, that output of y becomes the input, but now my input is the output. So x equals what? Y squared. So these calculators, you don't need to type this in, I just want to show you this. These calculators are really cool, and there's not any other calculator I know of that does this, where if I go to graph entry / edit, you see this option for relation here? So only these calculators allow you to type in any equation. So x equals y squared. Look at that again. Look what's there now. So see how we had the top square root of x and the bottom negative square root of x? But when I type in x equals y squared,
I ain't getting that.
okay, you don't need to. I just need you to look at the graph up here for this piece. Notice what happened when I typed in x equals y squared. Does it give me that horizontal parabola? Yes or no?
Yeah.
Yes, Mr. Kenny.
You see the blue there? So there's no blue. Now there is blue. Because, and you may not see it because it is exactly what we already had. It's just x equals y squared. They map to each other, right? And this is important, and it connects right here. If I wanted to solve for y and I take the square root, Now y is equal to, I took a square root, so I need a positive and a negative square root of x. So these are equivalent. We use roots with what are called polynomial functions. Don't worry about it here because we're talking about inverses at this point. So please understand, what is an inverse function? Or what is an inverse? The inputs and outputs transpose. Whether that's a graph, whether that's a table, whether that's an equation, an algebraic. So here's my inverse, Javon. Here's my inverse, where the inputs and outputs transpose. All right, here's where I need you to start. Well, one, I would take some notes on that, but I'm going to start us on something else in a second that we need to pay attention to. Okay?
Rod Wade, not Robert D. Garbage.
Go.
Mr. Kid, why do people do this?
What?
When they know your full name, why they do this? Like, why they just tell your full name?
Because they think they're cool.
Thank you, cool, son.
Rod.
So problem.
Rod.
Okay.
Cool.
You should like cheese.
You look like cheese. All right.
That's a knee slapper.
All right.
Please notice, right? We have now what we saw graphically there. The purple is my original function, y equals x squared. What did I draw here kind of as a dashed line?
Y equals X.
What line though?
Y equals
Y equals x, because that's what I reflected over to get my what?
linear.
Inverse, right? You're right, it's a line, but we want to recognize it is the line y equals x because that's what we reflect over to get the inverse. You will want this either on the backside or in that first little quadrant on your graphic organizer.
Can we put it on the back?
I just said you can do that.
Oh, my bad.
Either the first little quadrant here, we're going to do 2 more graphs though, or I would put it on the backside.
Look at this work. Let's go.
What did you do yesterday? Oh, you had to help my thing.
Doing the problem.
As soon as I had an AP stats exam, so I helped them in the morning, and then I went and worked on putting backsplash in our kitchen. It was awful.
Did you do it?
That was awful. We're not-
It's easy.
Backsplash ain't easy.
Dude,
Tile
put your
backsplash.
Tell backsplash is easy. Only thing you're doing is put them in the
Bro, me break. Bro, come on, bro.
You have to put mortar up, you have to make cuts around the electrical outlets, cuts around the light switches, it ain't easy.
I promise it's not easy. When you know what you're doing, it's not easy.
It gets cold.
Alright.
It's probably because you probably
I've never done backsplash, I've done floor tile before. We also should have done subway tile and we did not, that was a mistake. Alright, so what function do we now have? A cubic, right? Y equals x cubed, right? So, what's the core idea of an inverse function, Rod?
What you say? Say
What's the
again.
core idea of an inverse function? What is the core idea of an inverse function? What's transposing?
Inputs and outputs.
Inputs and outputs. But why? What was causing that transposing?
I wasn't gonna say this.
And it,
The reflection.
Thank you for helping out, Zakiah. A reflection across what?
Y equals X.
So, let's do some geometry here. Let's do some transformations. And let's do some reflections. Alright. So I'm going to take the point 2, 8. No, that's not 2, 8. 2, 8.
I didn't know where you taking them.
Like which points to use? I can technically use any, but I'm using integers. 2, 8. I'll show you though that it doesn't have to just be integers in a second. Yep. So good question. Thank you for asking that. Alright, here's 1, 1. Here is 0, 0. Notice 1, 1, 0, 0. Did it move at all?
No.
Why not?
It's stuck there.
I know, but why didn't it move?
I guess it can't move because of the problem.
Well, remember, if I'm reflecting over this line and it's already on the line, does it have anywhere to reflect?
No.
That's the big idea here. All right, so Zakiah, to show you that it doesn't matter which point. So what I did really quickly is if I think about y equals x cubed, 2 cubed is 8. 1 cubed is 1, right? 2 times 2 times 2, 1 times 1 times 1. What's 0 times 0 times 0? 1, negative 1 times negative 1 times negative 1. Negative 1 times negative 1 is what?
Negative, positive.
What's the negative times the negative?
A positive.
Positive, so I got positive 1 times a negative 1, which is negative 1. What's negative 2 times negative 2 times negative 2?
2.
That's going to be positive 4
Positive 4.
times negative 2 is negative 8. Okay. So, Zakai, I just chose those points, right? And so let's do a couple more that aren't perfect like that. Okay, so I'm just picking random points at this point. Alright, so let's look at some coordinates. Geometry again. Actually, that's not what I want.
How do you go back? Do you hit control?
Escape. Alright, negative 1.7 comma negative 4.87. So this reflection right here should have what coordinates? Sorry.
Negative 4.
How did Zakiah know, Brendan, that this coordinate right here would be negative 4.87 comma negative 1.7? What? The inputs and outputs are transposing. Was Zakiah right?
Yeah.
Okay. So does it matter which point I use?
Oh, no.
I was saying, even with those ugly decimals, it worked, right? And it's just one of those things that it's easier to use integers than it is to use those ugly numbers, right? So negative 2, negative 8.02, I was a little off there apparently. But same thing here. Okay, so let me ask this. We now have x cubed. Kendi, what's going to be my inverse for that x cubed? Squared?
You said cube.
So right now, I have y equals x cubed. And that's this function, right? That's an estimate of it.
I would triple.
So what would be the inverse of y equals x cubed?
I thought we triple.
So remember, a square root was the inverse of x
Squared.
squared. What was the inverse of x cubed?
No,
Cubic. Oh,
Not a cubic.
It's
Which root was it? A
Cube.
cube what? Root. Right? The inverse of x cubed was a cube root, or a third root. Remember how we talked about that?
Yeah.
So let's type y equals x cubed, or the cube root of x in. And so now this is what I do want you to pick up another calculator and just type this in. I need to make sure you know how to type in the cube root. You see this little caret symbol right here? The little arrow? Yep, that's called a caret. Okay. That caret symbol, Carly, you with me? This caret symbol allows me to put any exponent I want.
Right.
What's in gray above that caret symbol?
Here. Symbol.
Nah, the same. No, basically what you wrote over there with the 3. Yeah.
So it's a root, right? So here's a caret. Above it in gray is a root. But click on this root, because it's not a square root. Right? So control, and then the caret. Notice how it allows me to put what we call an index right here. And if I want a cube root, what index do I put?
3.
A 3, right? So it's a third root of x. And if I have done my job, what should this equation go through?
That line right there.
Not the line.
The point.
Shouldn't it go through all these
do.
transposed points?
Yeah.
It does.
I ain't doing
Oh man.
That's hard.
I don't know. Look at that. That looks like it's going through all those points for sure.
They like the DNA.
They do now.
It does now, doesn't it?
Yeah, now.
Kind of like that double helix from DNA. Can you hit the door for me real
You
quick?
know what's
Ron?
crazy? You said the index, right?
Yeah.
You know, math use a lot of English.
I know. Because we have to have a language to communicate these ideas. Like, guys, this is what math is at its core. There's patterns and relationships that we're seeing but we need to be able to talk about it, right? So we developed a language to talk about these patterns and relationships. That's all this is. All right. So I want you to notice here, with this cube root function, was this inverse a function? Look at this cube root, right? Was this cube root, this inverse, a function? Does one input map to only one output?
Yes.
So is the cube root a function?
Yes.
Very much so, right?
You said no. That's why.
But do you see how one input maps to only one output? We check that vertical line.
You just stand in front of that, I can see.
I got you. KB, you can't hold it for 8 minutes?
You thought.
8 minutes?
Hey,
Go quickly. All right. So let's look at something new. Not new per se, but let's look at, I'm going to put it here. Actually, I'm just going to put it here so it's next to it. Let's look at y equals x to the fourth. Okay? Y equals x to the fourth. Not quintic. Quartic, right?
Quartic.
What does that quartic look like to you?
Parabola.
It looks kind of like a parabola, right? Here's the big difference. Notice how it's a little flattened in here?
Yeah.
So a quartic, remember how many zeros does a quartic have to have? Not 2. It's quartic, so it has to have 4, right? That fundamental theorem of algebra. And so, how many roots are right here at this one point? It has to be all 4 of them, right? So, there's a quadruple root for a multiplicity of 4 right here. That's why it flattens out so much. But now, what we really want to focus on is the inverse. Anybody want to come just make a prediction as to a sketch of what you think the inverse of that might look like?
Righty.
Oh, no, I didn't know who had to go up there and explain, like,
Just sketch it. I just want a prediction.
I had to put my
What you said,
Man,
prediction
we're
what?
so
Say again?
scared to make the
Prediction
prediction.
what?
Huh?
Prediction what?
This inverse would look like.
Davion, you like that DB.
You want to sketch it?
I don't know. Because I entered it on my calculator.
Yeah?
Fourth, yeah.
But you did a fourth what?
Root.
A fourth root? Would a fourth root be the inverse?
Nah.
You don't think so?
Yes.
Yes.
I would think so, right?
Let me see how it look.
Now-
Miss King Jordan, let me see how it look.
Hold on 1 second, okay? What I'm gonna do quickly is my geometry. I'm gonna do my reflections. And I'm gonna reflect across this line.
Hey, you can't crawl back up through the window, you know why?
2, 4. I don't know why my calculators would be hitting the ground, do you?
Brother Dion.
Keep on trying to take your thing out.
Hey man, never been the son.
What was that?
Never had the son, man.
That was not just a,
The
that
next one
was
is
weird.
It was.
God.
Don't do it, sweet.
Okay, so let's look at it, right? Notice all I did was reflected my points,
I see that.
causing that
It's not.
the inputs and outputs to what?
Transpose.
Transpose.
Good job.
Teammate.
Notice,
Oh.
does that look familiar?
Excuse
Oh, no.
you. It's just skinnier.
It's just skinnier, but I mean, like, it's just a horizontal version of
Nah.
what was vertical, right?
Yeah.
Huh?
Why you want me to do it?
Who?
Michael. Michael.
I'll talk to him.
Michael.
Yo, chill, dude. What about you?
Why?
Alright, so
He just went right back.
function. So notice, Zakaya earlier mentioned, right, that she did a fourth root. So let's look at a fourth root here. Now, we're supposed to have a top and a bottom, but what did we actually get? Only the
top.
Only the top. Why didn't I get the bottom?
I know him out.
Is this
It's similar to a quadratic, right? When I say x squared is equal to 4, x could be a positive or a negative 2. if I say x to the fourth is equal to 16, if I do an even multiplicity, a positive 2 raised to the fourth is what? 16. A negative 2 raised to the fourth is also. So when we do a fourth root, an even root, we have to do a positive and a negative. Okay? What I would also remind you is this. I can just go to relation and I can transpose my inputs and my outputs. Notice when I transpose my inputs and outputs, does it give me that shape that I expected? No. Now here's the key that I want us to notice. And this is what I wanted you to take just a couple minutes to talk about with your small groups. And we'll end class on this note. Sometimes the inverse is a function. Sometimes the inverse is not. When do you think the inverse will be a function? So talk with your group just a couple of minutes. I need you to make a prediction about when will the inverse be a function. Hey, I need the conversations to be about the math. Guys, Cassie, Ty, I need y'all thinking about this question. When will the inverse be a function?
When it maps to one output.
When it maps to one output.
Does anybody see a pattern here?
I kind of see it.
They look the same.
Yeah, it's the same.
But they won't go.
Hey, these two inverses, are they functions? Wait. Are these two inverses functions, guys? Are these two inverses functions?
No.
So what's the pattern that these two inverses are not
They
functions?
map to one output.
Oh, definitely.
Oh, yeah.
Look again at the equation.
They're not going through each
Hold
other.
on, what
Them
you
even sides.
Look here, guys.
What you see?
Hey, right here. Those two power functions are what type of powers?
Even.
Even. These two are, so even degree power functions are not invertible.
Invertible.
So here's what I mean by that. Does anyone know what that suffix IBLE means?
No, I don't.
What you say what? Say again.
It should make you think about ABLE.
Able.
So able to what?
Invert.
Invert, right? Invertible just means that it's able to be inverted and be a function. So even degree power functions are not what? Invertible, but odd degree are invertible. You should at least make a picture of this and put it in your notes before tomorrow. Because I'm going to operate under the assumption that you know this. Guys, I'm going to operate under the assumption that you have this in your notes and you know this. Take a picture and put it in your notes before tomorrow.
I did.
Come on.
I ain't taking a picture. I had wrote the note.
You wrote some of the stuff I just finished writing before I was done writing.
Oh, no, I ain't know you right.
The brown part, you need that part.
I need to keep my show closed, bro.
I'm sorry. It's not.
Like this. Oh, I'm about to say.
They don't have nothing.
Wait.
You gotta look at me like that. Why you bring?
So I guess that's it.
No for today, just because I need to work with Cassie, because she needs to make up a lot of what she missed.
Oh, I gotta stay here.
Have you okayed it with your fourth block?
I have co-op.
Okay.
Well, it probably